Hello everyone, welcome back to my channel, and I am excited to have you here. Lecture number 14, our C++ programming series. In our last lecture, we explored advanced array covering multidimensional array, dynamic array, and real-world application. Today we will discuss something fundamental of efficient programming, that is searching and sorting. That is searching and sorting algorithm. Okay, that is using array. While we will focus on the theory today. Okay, understanding the concept is crucial before jumping into the practical implementation. I walk you through each algorithm, explain how they work, and provide real-world example to help you visualize their applications. We will cover the coding aspect in the next lecture. So stay tuned for that. Okay. The first question is, why searching and sorting are important? That is, why searching and sorting important. Okay, the question is, that is, searching and sorting are essential algorithms that are used in almost every software. That is, it's used in every software that you are using. Okay, that is the first one. That is, searching is about finding a specific element. Searching, finding a specific element that in a database, or we can say dataset as well. Okay, that is, example is, that is, think of a library catalog where you search for a particular book. Okay, this is meant by the search. The next is sorting. That is about organizing data in a specific order. That is, organizing data in a specific order. Okay, like arranging exam score in ascending order, like who got the highest mark, who got the lowest mark, like using ascending and descending, or we can say sorting product by price on an e-commerce website. Okay, these algorithms optimize data processing, reduce time complexity, and enhance the overall performance of your program. Let's start with the simplest search algorithm. That we are now going towards search algorithm. Okay, the first one is linear search. I'm writing it here. That is linear search. Okay, linear search check each element in an array one by one until the desired value is found or the entire array is traversed. That is, in simple word, linear search check each element in an array one by one. Okay, that is, it's ideal for small dataset or unsorting array. That is ideal for small dataset or unsorted arrays. Okay, let's take a real world example. Imagine you are searching for a friend name in a printed contact list. If list is not alphabetized, you go through each name sequentially until you find the one you are looking for, right? Like if there is anything like list, like number 1, number 2, number 3, number 4, number 5, and this is a hard copy. So you have to check one by one name, and then you find that friend name. Okay, this is mean by linear search. The next one is binary search. That is, okay, which is much faster than linear search. That is, the first point is much faster than linear search. Okay, but work only on sorted array. Like you have to first sort, then it's work on. So the concept is like binary set, divide the dataset into half. Like divide datasets into half and eliminating half of the element in each iteration until the target value is solved. Okay, that is eliminating half of element in each iteration until the target value is found. Okay, that is this is for a perfect for a large sorted dataset like dictionaries or sorted customer dataset. So the example is, let's take a real world example, that is, think of how you use a dictionary to find a word. Instead of flipping through every page, you started near the middle and decide which half to search in and keep narrowing it down. Like if you have a dictionary and I have to something find like A and K. So the first page is of A, and then for K it's basically I will just go to nearby like J letter and I letter. So I know the middle is K letter. So then I will go to find that as well. Okay. So that is the key comparison. The first one is most important for linear search. Linear search. That is the time complexity. If I know you did not know what is meant by time complexity, so think about this. I will learn you as well. Like I will make a video on it as well. So it's O n O not n. Okay, so this is the time complexity of linear search. The second one is binary search. For this, the time complexity is, I write the same as, is O not log n. Okay, so directly remember this for what exactly. The next one is we are moving further to the sorting algorithm. Okay, or you can say sorting algorithms. Now we will dive discover like we have discovered search. Let's move on the sorting algorithm. So sorting is essential for efficient data retrieval, visualization, and analysis. Okay. So our first is bubble sort. Bubble sort. Okay. This is the one of the simplest sorting algorithm. One of the simplest sorting algorithm. Okay. It is basically repeatedly compare adjacent element and swap them if they are in the wrong order. Like if we are taking 1, 2, 3, 4, so it's first compare, it's okay, then it's again compare, then okay, then it's again compare, then okay. If 1, 3, 2, 4, then he check, it's compare, okay, then he come check, then swap, then okay, and then again compare. Oh. So this is mean by what is meant by the bubble sort. It's suitable for small data set. Suitable for small data set. Okay, but inefficient for large, but not for large. Okay, so like think of a one real example, that is real example, like arranging playing cards in ascending order. You keep comparing and swapping card until the entire deck is sorted. Right, like we are taking an example of deck card, so you can take another example as well. I will take this and I will tell you as well what is meant by that and how you can apply bubble sort in it. So the next one is quick sort. A highly efficient algorithm that uses a divide and conquer approach. That is a highly efficient algorithm that uses a divide and conquer approach. Okay, so the concept is it's pick a pivot element participation the array into two sub array based on the pivot and recursively sort them. That is, in short, it's pick a pivot element parties partition the array. Basically, it's divided into two parts into two sub array based on the part. Okay, and recursively sort them as well. That is, it's ideal for large data set. That is ideal for large data set. Okay, so the real world example is bubble. Like for quick sort, imagine sorting folder on your computer, your group file based on the criterion. That is, like we are taking example of size. Like sort each group individually and then merge them. Okay, so this is the example of real world of quick sort. So the so now we are comparing between sorting algorithm. So the first one is bubble sort and the second one is quick sort. That is comparison. So we are taking like table, that is bubble sort and quick sort. It's simple to implement. Okay, the first point is simple to implement, but has a time complexity. But has a time complexity of O not n square. This is the time complexity of bubble sort. And this is for the quick sort, it's more complex, but far more efficient with an average time complexity of n log n. It's basically O not n log n. Just O not n log. This is the complexity of quick sort. So I will just cut this part. I hope you know what is meant by this, like quick sort and bubble sort. I've just explained you the basic. So I will again explain you in deep in the tomorrow video. Okay, so just a second. My laptop is lagging. So yeah, just a second. Give me two minutes. So yeah, once it started again, so I will go to the other. So yeah. So the now last one is that is application in real life. Now let's discuss where these algorithms are used in real world. Okay. Now we take what is meant by bubble sort, quick sort. searching as well. Okay, linear search, binary search. So what is the real world example? Like take a first application of e-commerce website, like e-commerce platform. Okay, searching for product or sorting them by price. That is searching for product and sorting by price. The next is stock market. That is sorting stock price or searching for specific data of his stock, or you can say specific stock data. Okay, the third one is navigation system. Navigation system. Okay, that is finding the shortest route. Okay, and the last one is databases. That is optimizing search query and organizing, just a second, large data set for quick retrieval. Okay, I hope so you understand what is meant by the e-commerce platform as well as stock market, navigation system, database. So the understanding these algorithms allow you to write, optimize code and build scalable systems. So this is all for today. So the question is what next? That's it for today. Okay. We have covered the theory behind linear search, binary search, bubble sort, and quick sort, along with their real world example. In the next video, I will dive into the practical implementation of these algorithms, and again we are recapping all these concepts with deep knowledge, and I will walk you through the C++ code step by step and explain how to write efficient reusable function for searching and sorting. If you found this session helpful, don't forget to like, share, subscribe, and share with your fellow programmers. So thank you for watching and have a good day. So bye bye. So in next video we are going to take practical implementation. Bye bye.